A diver running 1.6 meters per second dives out horizontally from the edge of a vertical cliff and reaches the water below 3 seconds later. How high was the cliff and how far from its base did the diver hit the water? All right, first step, you always want to draw it. So we got a crazy diver here. I gave him a shower cap. Maybe that was a bad haircut. But he's jumping straight out at 1.6 meters per second, and we're told that it took him 3 seconds to hit the ground. We don't know how high the cliff was, and we don't know how far out he was able to go before he landed. So we're still looking for these two pieces of information, basically. We're looking for delta y and delta x here. Um, so this one's particularly easy because they gave you the link. They gave you time, which is the most important element in these problems. So we're actually going to kind of go both ways here. We're going to use time to get the information in the y direction and the x. Nice and easy problem. So since we're accelerating in the y direction, we use our acceleration formula, delta y equals 1/2 at squared plus vit. And in this case, once again, the starting velocity was 0 in the y direction. I know he jumped out at 1.6, but that was all to the right. So as far as the y direction is concerned, our starting velocity was 0. Vy is 0 when he jumps. So we get to scratch all this stuff out. And then 1/2 of a is negative 4.9. And then t squared, since t was 3, t squared is 9 seconds. So we just work that out, and you get negative 44 meters, which means he fell 44.1 meters down. And then next we're looking at how far he went in the x direction. And since the velocity is constant in the x direction, right, gravity is pulling down. It's not pulling you left or right. So your speed in the x direction just stays the same. We're just going to use the constant velocity equation. Delta x equals bx times t. If you're going 1.6 meters per second, and you do that for 3 seconds, then the total distance you go over here is 4.8 meters. Pretty easy. Now, here's a sweet trick, though. This probably looks like it took a bit of thought, and this was kind of a crazy number, but I want to show you how you can do a problem like this in your head. It's a pretty cool trick. Our buddy average velocity is going to make a comeback here. So check this out. They told you at the beginning that the rock took 3 seconds to fall all the way down. So I'm going to use an approximation since we're doing it in our head. Instead of 9.8, I'm going to use 10, just to show how quickly you can get really close to the right answer. So if you fell for 3 seconds and you didn't throw it up or down, you just threw it to the side, then your final speed in the y direction is 30, because every second you got 10 meters per second quicker in the y. Then after 3 of those seconds, you're going to be going 30 meters per second in the y direction right before you hit the ground. Now, if you started at rest in the y direction and your final velocity in the y direction was 30, then your average would simply be in the middle of those two, 15 meters per second. So your average y velocity was 15. Let me put the negative on that. I forgot to include that here because technically it's going down, but the math is still the same. Now, if you're falling at an average rate of 15 meters per second and you do that for 3 seconds, the math is easy. You fell about 45 meters. Now that doesn't match what we got here exactly because we used 9.8. So we got 44.1. But that's pretty stinking good. Only about 2% off, and we did it in our heads in about 5 seconds. So that can be a very useful trick. And if you ever see me in class kind of cranking these problems out in my head, it's pretty likely that this is the method that I'm using to estimate how high something is, or to estimate a time, or something like that. Average velocity is a pretty nice trick when it applies, and with a little bit of practice, after you've done enough of these problems, you'll know when you can get away with that shortcut and save yourself some brain cells on exams.